This is activity number 1 for lesson B-17. For this activity, you will need the assembled Raspberry Pi setup from previous activities, the assembled circuit from the last activity, a blue LED, 2 1000 ohm resistors, 2 short male-to-male jumper wires, a 2200 UF capacitor, a 220 UF capacitor, and a long male-to-male jumper wire. In this activity, you will build a small LED circuit that will be powered by 3.3 volts. You will then add a capacitor in parallel that will charge while the LED is illuminated. At that point, you will remove the 3.3 volts from the circuit and watch the energy stored in the capacitor continue to power the LED. First, power off your Raspberry Pi so changes can be made to the breadboard. Using the circuit you built in the last lesson as a starting point, remove the 2 short jumper wires that are relaying I2C communication between the temperature sensor and the display. Disconnect the remaining I2C communication lines from the temperature sensor and relocate them to the display. Relocate the SDA line from F37 to E46. Relocate the SCA line from F36 to E45. When completed, your circuit will look like this. The temperature sensor is no longer required, so go ahead and remove the temperature sensor and its power wires from the circuit. Next, you'll build a small LED circuit that will be powered by 3.3 volts from the Raspberry Pi. Add an LED with the cathode in H61 and the anode in H59. Place a 1000 ohm resistor between F51 and F55. Place the other 1000 ohm resistor between G55 and G59. Place a short jumper wire to connect 3.3 volts between P152 and H51. Place another short jumper wire to connect ground between N161 and F61. Power your Raspberry Pi back on. Since the LED circuit is connected directly between 3.3 volts and ground, the LED will turn on as soon as power is applied to the Raspberry Pi. Carefully remove and reinsert the 3.3 volt jumper wire at P152. With the jumper wire removed, the circuit no longer has a power source and the LED will turn off instantly. With it inserted, the LED circuit will receive power and the LED will turn back on. So next, you're going to add the capacitor to the circuit, but it's very important to make sure you've correctly polarized the capacitor before inserting it, or your components could be damaged. Carefully insert the 2200 UF capacitor into J55 and J61 with the negative of the capacitor in J61. Remember, the negative side will be marked with a gray band. The capacitor will begin to charge as soon as it's inserted into the circuit, but the LED circuit in parallel with the capacitor will be unaffected. Carefully remove the 3.3 volt jumper wire between P152 and H51. 3.3 volts will no longer be supplied by the Raspberry Pi, but the LED will remain on, temporarily running on the energy stored in the capacitor. You can reinstall and remove the jumper wire if you would like to watch the charge and discharge cycle again. Power down the Raspberry Pi so additional changes can be made to the circuit. You'll now modify the circuit so the capacitor circuit can be charged by a GPIO pin. Remove the 1000 ohm resistor and LED that are in parallel with the capacitor. Keep the 1000 ohm resistor handy as you will be inserting it into a new location in a moment. Next, you will add the 220 UF capacitor and the 1000 ohm load resistor to complete the capacitor circuit. Temporarily remove the 2200 UF capacitor from the circuit to allow for easier access to add these new parts to your circuit. Add the 220 UF capacitor between H55 and H61. Ensure that negative of the capacitor is inserted into H61. Remember, it's very, very important not to put the capacitors in the circuit backwards. Next, place the 1000 ohm resistor between G55 and G61. Then go ahead and reinstall the 2200 UF capacitor between J55 and J61 with the negative in J61. The last circuit modification is to connect the 1000 ohm current limiting resistor to GPIO 20. Connect the long jumper wire between J19 and H51. Double check all component placement and capacitor polarity to ensure it matches my circuit exactly, and then power on the Raspberry Pi. Once the Raspberry Pi is fully booted, continue to the next activity where you'll build a program to use with this circuit.